Okay.
We can start. Eyes on camera, straight up ahead. Smile in 3, 2, 1.
Welcome to another episode of the 4 Degrees podcast. Today it's just the two of us, and we are going to dive right into it. We are talking about scary stuff. Yeah, scary stuff. What are we talking about today, fellas?
As every episode.
Yeah, the other episode was deep. Today it's scary stuff.
Yeah, it's in some degree.
Yeah.
It's going to be even deeper.
Yeah.
At least in one aspect. I want to. I guess we can break it. We want to talk about two connected phenomena, if you will, frameworks, theories that are planetary boundaries and so-called tipping points. Exactly. I feel it sounds scary. It's a bit like you're always thinking of like a seesaw. Like at one moment you're here, and then all of a sudden,
you don't want it to.
The weight changes,
the
attribution changes.
Yeah.
But before we get into it, you were in Switzerland last year.
Oh, yeah.
For a summer school.
Was
it last year?
2024.
Wow, that's so long ago.
It's so long ago now.
So
It was like
long
2
ago.
years ago. Yeah.
I'm going on a bit of a segue.
Yeah.
Do you remember, or do you know the longitude of? Is it the longitude? Sorry, the latitude. Latitude. Longitude.
Yeah.
Right? Of where did you go? Geneva.
Of Geneva. No, I don't. I don't. All I know is it was in Switzerland.
Yeah, I also don't. But I'm from somewhere in Germany, and the latitude is about 45 degrees where I'm from. And that's roughly where in North America, where Boston is located, or even a little further up, in fact. So if you've been following the news, and you know about climate and weather, of course, all the phenomena we talked about, heat waves, cold spells, blizzards, etc. Have you ever wondered why on the same latitude the climate is so different, so much more temperate in Northern Europe, especially northwestern Europe, closer to the North Sea, the Atlantic Ocean, than it is in North America?
Yeah, I want to say I've thought about it, yes. I've thought about, especially even if it's a good thing that you brought that then on the same latitude, but they're experiencing totally different things. And I've thought about it, and I'm like, what's going on?
Because you'd think it's all the same.
Yeah, I would think there would be, if there is rain that side or there is a cold spell that side, then obviously this side should be feeling a bit of the cold spell.
Or at least should have the similar climate.
Yeah. I've thought about it, and I'm assuming you have the answer. My answer would be it has something to do with the ocean.
Wow. Okay. That's a good guess.
But yeah,
I want to say it's mostly correct.
Okay.
So when I was growing up, and we would sometimes like travel for like holidays to southern France, whatever, to the Atlantic side.
Yeah.
My dad would oftentimes bring up the Gulf Stream as a phenomenon, which is why the climate is more temperate, why we get like mild winters, still warm summers, but specifically mild winters. And the Gulf Stream is part of a phenomenon in the Atlantic Ocean that we call AMOC.
Yes.
Acronym
Acronyms.
time. So what does it
What does it
mean?
mean?
What does it mean?
Let's look it up.
Let me unlock my face. It stands for the Atlantic Meridional, and this is why I use my phone, because I always forget the term. Meridional overturning circulation.
Overturning circulation. Okay.
And what does that mean? What does it do? Do you know? Roughly. I feel like a lot of times we should have marked in this podcast.
Right? We should have Mark, and then he sits right here and then he tells us
Yeah, he
exactly
tells
what
us.
that is, because I think he will say it at the top of his head. I want to read it.
Yeah.
I want to read what it is, but it's also like a long explanation
Oh,
that
it's
you
a
might
long
lose
term,
me
right?
the first time I say the first line.
Okay. So let me try to
Yeah,
try to make it short,
Yeah.
unspecific, because also we want to try to explain things in an easy
Yes.
but correct manner.
Way.
Essentially, what the AMOC is a circular oceanic water flow. Like you imagine, like vast amounts of water. When you think of the ocean, a lot of times you don't anticipate that that the bodies of water are moving within the ocean.
Yes.
But it's very much like a reflection of our atmospheric system, where we actively experience wind, and very similarly, there are those currents in the ocean.
Yeah.
Water currents, not air currents, right? So there's a current, a surfacial current, of hot water running from the tropics, so the lower latitudes, on the Central and North American side of the world towards the poles.
Okay.
And eventually the water has increases in saltiness, and the more north it moves, it becomes colder, so it starts sinking, and then it comes back, if you will,
Yeah.
then we're back to the deep, right, on the lower altitudes of the ocean, and moves towards the tropics again. And it's all connected to this globally spanning system of oceanic currents. Okay, now we roughly know. Now we roughly know what it means. So we'll get some, because to some extent the ocean surface temperatures are relatively high. There are westerly winds, which means winds coming from the west to the east, and basically transporting this surface heat, if you will, towards Northern Europe.
Yeah.
Okay,
So basically, if it gets warmer in the tropics.
No, what is it exactly? What does it mean? Because remember, we wanted to talk tipping points,
Yeah.
planetary boundaries.
So is AMOC a tipping point?
We could probably say it is. And we've there are various tipping points. So and AMOC is one of them, was affected by one. And that again then ties into planetary boundaries.
Yes.
We wanted to talk about. So we've recently read the news that AMOC, as we want to call it, is slowing down. Right? Have you read this?
Yeah, I saw that it was slowed down, and this is because of climate change.
Yeah.
And
so
what are the consequences?
Yeah, what are the consequences?
Because I'm assuming, from what you've explained, what an AMOC is.
The
AMOC, what it is.
There's, by the way, there's a similar circulation in the northern Pacific.
Yes. Right. Then what if the warm water gets warmer than it usually is because of climate change? Then does it mean then that the water that would get, as it gets colder, that colder part is also getting warmer? Considering that's where the poles are, then it's basically melting all the, at the same time, it's melting all the ice that is also in the poles quicker than it. Oh my days.
Yes, I know. It's super complicated. It really is complicated, and that's one of the challenges, I guess, for us, but for everyone.
Yeah.
Right? And we are dealing with extremely complicated stuff. So when you open a news page and it tells you the AMOC is slowing down, what does it even mean? What does it mean now? What does it mean in the future?
And what does it mean for the places that
Yeah. What
like
is it?
are on either sides.
Yes, on other sides of the Atlantic, but also, and what we really don't know is how does, or what we don't know enough about is how does the AMOC as part of the climate system influence other parts of the
Yeah,
climate
yeah,
system
yeah.
around the globe.
Yeah, I've been seeing a lot of
Right.
push on like more research needs to be done on how the the effect of climate change on the AMOC has on regional areas and all of that, because we have an idea, yes, of what it does. But when it comes to what I don't want to use the word downscale, but when it comes to like the regional areas, what does it mean? What does it mean for the poles specifically, just them?
Right.
Because it's like 1.5. We could say 1.5, that 1.5 that we say it's a global goal. But what does it mean for Southern Africa? What does
Yeah.
it mean for Eastern Africa? So what does it mean for like all that? I've read that there's more push for like more research that is needed on there.
Always push for more research.
Yeah, because it's complicated. Like it's
Yeah,
like
and
one time we get it, then like, do we really got it? Then we progress and like make more efforts onto certain things.
But let's close the loop on this circulation. So I guess the worst case, what we're looking at and what projections are currently hinting to is that there might eventually be the situation that the whole AMOC will come to a stall. It's already, if you will, slowing down slightly. There's evidence that the circulation is less intense than it was before the Industrial Revolution.
Yeah.
And that will essentially mean that this whole experience that we would have in Northern Europe, that will have a temperate climate, warmer winters, more temperate summers, will change entirely. So we're looking at much colder weather, much colder climate, in fact. And that will specifically affect the British Isles, Scandinavia, and perhaps the oceanic regions of France and northern Spain.
Then they won't have summer.
They won't have summer. I mean, they probably will have summer. It'll just look very, very different. And why that happens is, and you mentioned it exactly, through climate change. And if you will, it's counterintuitive. But what happens is with rising sea surface temperatures, the water will still move northwards, but it will become more difficult for that water to sink, because the more energy is required. And through climate change, we'll have an influx of sweet water, fresh water. We call it sweet water.
Oh, you call it sweet water?
We call it sweet water.
Interesting. I didn't know that you guys call it sweet water.
It's so sweet because it's sweet or salty, right?
Oh, okay. You were not innovative with that. You're like, yeah, salty, sweet.
Yeah, it's easy.
Okay.
At least it's not called pepper. Pepper water.
We call it fresh.
Fresh, yeah. So fresh water, where's it coming from? Because the Greenland ice shield is melting. And currently, mostly what has been melting in the North Sea is Arctic sea ice, which contains salt already. But water that is stored on the Greenlandic ice shield contains fresh water, which then means that the degree of salt in the surface layer is decreased, which means it will also add to a lack, or that circulation, that sinking of the surface water becoming less likely and more difficult.
I feel like we need a board.
So at the end of the day, it'll just, the surface level and the lower levels will not change anymore. So it will become, well, if you will, come to a stop, come to a halt. That's a risk. I'm not saying it's going to happen, but there's a projection, and that is what we would call a tipping point,
which is where we don't want to get to.
We don't want to get to.
And you also mentioned another tipping point of this Arctic ice sheets melting. they've reached already their tipping point because they're melting.
The
Would we say they've reached their tipping point?
I guess it's getting to a tipping point, but maybe we should take a moment to actually explain what a tipping point is.
Yeah. What
Do
is
you
a
wanna do
tipping
it?
point? A tipping point. A tipping point is a state that in the earth system or in the climate system where it gets that any change that will happen, a change that will happen to it will either lead to something that is irreversible or will lead to like cascading, like continuous changes that will be difficult to stop, and it's like a high risk state, so to say. It's like a high risk state. So for the ice sheets, we could say their tipping point is reached, not reached, because not all of them are gone. But also it means the temperature that we are in right now is not good for them because they are melting.
So we're basically moving from a more or less static situation in the Earth or the climate system to something that, if you will, now deteriorates on its own.
Yeah.
Right?
So now, for the previous studies, they had actually gotten to the conclusion that above 1 degree was not good for the Arctic ice sheets. Above 1 degrees global temperature was not good for them. So above 1.5 is still not good for them.
So
above 2,
it's not getting better. It's not
above 2, it gets worse. Like above 2 means they will melt faster. Above 1.5, they'll melt faster, but not as fast as 2. The idea is for not for them to. We're not necessarily they shouldn't like melt at all, but all that water that is held in the Arctic ice goes to the ocean, and the areas that are mostly impacted immediately by all that melting is the coastal countries, coastal cities, coastal,
because specifically
sea
ice
level.
on the on, if you will, ice shields on land, like the
the ice sheets are
Greenlandic
on
ice
land.
shield.
That's also, I think, a
This is
thing
what-
that people forget. The ice sheets are on land.
parts of them, like the Arctic sea ice, for example, is in the ocean. So the melting of that sea ice will have little effect on sea level rise. It will have some because of the degrees of fresh water and seawater, but the biggest effect will come from melting of ice from terrestrial from land mass. And another curious tipping point that you mentioned is exactly so there's a tipping point for the ice shield in Greenland, but also for Arctic sea ice, and it's a very, I guess, logical and scary one, and it's got to do with both warming temperatures and an effect that we call albedo, right?
The albedo effect.
So this is why also temperatures relatively increase more in the Arctic regions than they are in, let's say, areas around the equator, because of that effect. So generally you'll have a high albedo, which means a lot of radiation
Being reflected
that hits
back.
the ice is reflected back, right? But once the ice starts melting, that area of reflectiveness, if you will, decreases, and now all of a sudden it doesn't only decrease, but the radiation now hits the dark ocean surface, so it's absorbed, which then again increases
The
ocean
heat.
temperatures, which lets the ice melt even quicker, which again reduces the albedo, which lets more radiation reach the water. So that's an accelerating tipping point.
Yeah.
Right?
It is.
Very scary.
It's that's why I said today is a scary episode, because
So we have we thought of like a a point of hope to end on.
A poor hope is
Let's not get there yet. We'll
yeah.
save
I
it
do
for the
have.
end.
I
We'll
do
save
have
it for the
two.
end.
I have two. I always
Okay,
have hope.
perfect.
I have two.
Perfect.
Oh, I actually have three. Yeah.
Okay,
Always have
perfect.
hope.
There always have to be 3 or 5.
Yeah. Yeah.
Yeah.
And all these tipping points that we've talked about, there is tipping points, and then we are also putting in words that are planetary boundaries.
Yeah. So what are those, and how do they interact?
Planetary boundaries, a framework that was that the world came up with, scientists came up with to explain the 9 boundaries that humans should not surpass for the Earth system to function properly, so to say, or to function in harmony, so to say.
Like to be stable. as
Yeah,
well.
to be stable.
As well,
So
yeah.
there are 9.
Do you know them by heart?
I know some. Climate change is a planetary boundary. It's a boundary that we don't want to surpass. We don't want to surpass 1.5, ideally, and with the aim to not pass 2.
2
2
planetary
degrees,
boundaries.
2 degrees above 1900s.
And you know what the scary thing is
Yeah.
as well here? And we don't want to make this about fear.
Yeah, what is it?
That climate change is only one of the 9 planetary boundaries.
Yes, it's only one of the 9.
Right? But let's keep going.
And then number 2 is what we would call a biogeochemical processes, which has the phosphorus cycle and the nitrogen cycle. The amount of nitrogen that we emit, the nitrogen cycle, if you will, it involves all the fuels, all the fertilizers that we put, all the nitrogen that gets out of the land back to the earth, like doing this round, right, like a carbon cycle, so to say. But for nitrogen.
Sure.
And a phosphorus cycle is also the same. But the more, let's take, for example, pesticides, fertilizers that we use, we're adding more nitrogen, which brings this imbalance. Again, nitrogen, when mixed with oxygen, which contains nitrates, becomes a greenhouse gas emission, which is part of the emissions that are not good for climate change.
So that even feeds into the
So it's
other
like,
planetary boundary.
Another planetary boundary. So we'll put a picture. I think we should put a picture at the end, or a link to like a planetary boundary picture. It's a circle because they're all connected. So they're not different. It's a circle of like one thing has all these things, but they are so interconnected. So there is that one. There's that one that we shouldn't pass. But we'll talk about how many we've passed, how many we haven't.
Yeah. So we're at 2 now.
We're at 2.
What else is there? I'm going to throw in biosphere integrity.
Biosphere integrity. Okay, explain that one.
Which includes genetic and which measures genetic and functional biodiversity loss. So thinking about the biodiversity in two aspects. One on the from a I guess genetic or species perspective, the very basic terms, the amount of the variety of different species existing, and the other one is the amount of biomass, if you will,
that we have
the biodiversity.
Okay, that also is tied to climate change.
It is very much tied to climate change, and we've talked about this many times.
We've talked about it many times. Yeah, we have.
How climate change is negatively affecting both of those aspects of biosphere integrity.
Yeah. Another one.
Freshwater systems.
Yes, freshwater systems. We have the green and the blue. The green is how much would call
sweet water and
sweet water and dirty water.
Salt water. No, sorry, I'm mixing up. We should say freshwater
and salt water. Is how much the freshwater systems is how much freshwater we actually do have. How much do we have left for everyone? Because if you didn't know, what we drink is fresh water. The biggest part of the earth is covered by salt water.
In the oceans.
In the oceans. What we have in the lakes, in the dams, in the wetlands, in the springs
in the springs, the aquifers, the
Yes,
groundwater.
the groundwater.
Yeah,
Those
very
that's the
important.
fresh water. That is what we have, that we can use straight, either for drinking, doing our laundry, bathing. I'm sure you can't bath. Every time you go to the ocean, you go home and bath with fresh water, and that's
Ideally.
not a lot.
It's, yeah, it's a,
So there's that boundary. Like if
which
we
means the depletion of
freshwater
freshwater
ecosystems.
resources,
Yeah,
aquifers, especially through agricultural use, etc.
yeah, and groundwater.
Yeah.
Taking a lot out of the groundwater until it's like
Yeah.
the groundwater
Depleted.
levels are like really low.
And a lot of times we're talking about very, very old bodies of water that have formed for sometimes millions of
Yeah.
years. So
Yeah,
they won't just be repleted or refilled by a couple of like heavy
years.
rains.
Yeah,
Right.
yeah, yeah.
And then there's land use change.
Yes. Ooh, land use change. We had a chat about this
Yeah.
one just before. What is it about? Yeah, we're going on and on about what is it really about. But I think land use change is about how much land we clear for our own good, specifically urban development or even agriculture,
Agriculture is a big part. Yeah.
which is a big part. Like we clear land for agriculture a lot, and sometimes we clear it in some ways that is like we burn the whole forest or ecosystem that was there for us to put corn or for us to put, I don't know, something that we really, sunflowers or for food, so that which is seasonal as well. So sometimes you end up that land that used to be green, or that land that used to have such a biodiversity, like such a rich ecosystem, ends up being one ecosystem that we have created ourselves. Either it's just now sunflowers, and it gets cleared when sunflowers are ripe, and then the next we wait for another cycle. Okay, it's cleared, we put more sunflowers. So now this has been changed altogether for, that's a planetary boundary.
With immediate effects on the climate change
Yeah.
boundary, the biodiversity boundary, the freshwater boundary. So it's, you can see it's, as you said, it's very much connected.
How many are we on now?
We're on 6. We have. I'm gonna read out the rest. I have
Yeah.
a little cheat sheet here. We were talking about. No, we were not talking about ocean acidification.
Yes.
There's stratospheric ozone depletion,
Yes.
atmospheric aerosol loading,
Yes.
and novel entities.
Yeah.
That is,
How much we are introducing into the environment.
which exactly, it's like entities being, let's say, chemicals, pollutants that haven't existed prior to, if you will.
Yeah, that
Human-
actually usually
human
change
use.
even the biophysical
Yeah.
state
So
of.
plastics, for example, is a great example.
Mm-hmm.
And through plastic pollution, plastics in the form of microplastics, for example, enter into the food chain with, again, immediate effects on,
Yeah.
on biosphere integrity,
Yeah.
but also human health.
Yeah, yeah. For some cases, it's even worse that their genetic actually now gets tied with like all these plastics and stuff like that. It's crazy.
Yeah.
But we have this, what is it? The stratosphere, the ozone depletion,
Ozone depletion and aerosols.
and
in the
aerosols.
atmosphere.
All these aerosols that we introduce again into the environment by burning of certain things.
Yeah.
It's all tied together.
Traffic as well is a big part of that.
Traffic, yes. So, do you want to guess how many we passed in 2025? Okay, let's start
Meaning-
with 2009.
2009.
How many had we passed in
Yeah, it
2009?
should have been 2009. I would want to say we should have been safe.
Yeah, we were kind of safe actually.
Probably compared to now. So mind you, that whole framework, if you will, is only or has only come up in the early 2000s.
Yeah,
Right.
yeah,
So that we actually try to measure,
yeah,
put this into like a framework, the
Yeah.
entire like Earth system,
yeah,
to be able to make calculations, projections, etc., based on based on those singular items. Okay, tangent over. 2009. I'm gonna say. Oh, it's gonna be an interesting one. I'm gonna say 2.
Yeah, it's actually
Yeah?
true. Yeah, it's true. We'd only passed 2.
Okay.
And the
2 out of 9.
2 out of
Still,
9.
mind you, that's still not great.
Yeah, it's still not great. No, still not great. But I just want you to see also how the progression has. How climate change plays a big role in passing almost all of these other.
Which ones were the 2 that we had surpassed?
Okay, now I would have to fact check that, because if I say there's 2, I don't want to say there's other 2.
But we can also explain it later.
Yeah,
But
we had
there's
paused.
One, okay, because there's one I have in mind, and it's probably not even there in 2009.
We had paused the biosphere integrity and the biogeochemical flows.
Okay. Wow.
Kind of, I was thinking nitrogen cycle. I was like, that one I'm not. We've been, but that one is also because of the industrial evolution. Nitrogen cycle, the nitrogen in its gaseous state stays in the atmosphere for a long time, and if we continually produce more and more and more, it stays a lot longer.
Yeah.
So we'd passed those 2,
Okay.
and in 2025, unfortunately, we passed 7.
7 out of 9.
Out of 9. The only 2 we
If I
haven't.
were good at math, I would say this is more than 70%.
I
That's
think so.
probably-
I think it's more than 70%.
Yeah.
But most of them have been passed due to climate change.
Right.
So most of them, because it's getting warmer and warmer, most of the land is cleared. Most of the land is cleared by the impacts. Most of the land is cleared for other things that we are planning on doing to counter what we have done. Like most of the other things is like, it's just like climate change exacerbates every other boundary. And unfortunately, that's where we are.
So what does it mean if we say we've passed those boundaries in 2025?
Yeah.
Is it a singular event, or what does
So
it mean
I
for
think they
2026?
Yeah, I think they calculate them every 3 years. Yeah, 2009, 2015, 2023, 2025.
Sure.
So it used to be like every 5 years, I think, and then they started like doing more because of more impacts. You get to like try to like see where we're at. But I think also mainly because we have gotten better in some of the things that we can predict. But there is also levels to like passing these things. So there's the green level, which is like we are stable. Then there is we are entering a risky area. Then there is a high risk zone, which ties to the tipping points, where the high risk zone, you're saying, if we continue in this state, the effects might not be, we might not be able to counter these effects. We might not be able to come back from this. That boundary might be like broken, like might be passed to an extent that we can't go back. Like it's irreversible damage so that's how planetary boundaries would be like tying to tipping points. But yeah, I want hope.
Yeah.
I want hope because we've talked about deep stuff.
It's
Where's your hope?
my hope. I'm gonna tell you my hope, but it's it's with how do you call it? One crying, one laughing eye. That's not a saying, but is it?
Are you making it? We can write it down.
Yeah.
Yeah,
Is it?
one crying, one laughing eye.
Yeah.
Yeah. Okay, we're gonna write that down. Put your name under it. Put it in the student companion.
Okay, perfect. I'll maybe in the comments we'll hear how it actually what the word actually is. Planetary boundaries. There's one we mentioned it, ozone depletion.
Yeah.
And I would want to assume that we were on a way to pass it probably earlier in the 20th century.
Yeah.
I still recall that we were genuinely concerned in the early 90s that like soon we would only be able to go outside with an
Yeah.
umbrella,
Yeah.
or even not going outside at all,
Yeah.
because the ozone ozone layer
Ozone.
had significantly depleted, specifically on the southern hemisphere,
Yeah.
around Antarctica, tips of South America,
Mm.
and specifically Australia.
Yeah.
And that means that some harmful radiation from the sun is not filtered out through exactly that ozone layer,
Mm.
but reaches the Earth, with consequences for human and biodiversity health.
Yeah.
But that changed
Did change.
through the so-called Montreal Protocol. I'm going to
Yeah.
say it's probably not the only cause for
Yeah.
that change, but
Yeah.
there was, and we mentioned it a few times,
Yeah.
there was an international agreement in 1998 that banned certain chemicals that were causing the depletion of the ozone layer.
Yeah.
So after that time, the ozone layer was actually able to come back. We had not reached, if you will, a tipping point yet where this reversal would not be able to happen, which is great. So probably on that planetary boundary, we were quite high up in the 90s when the framework didn't exist yet.
Yeah.
But now we've tracked back a bit. Is there hope? There is hope. Would I say, I'm very critical about what the law can actually do to
Yes, you are very
to
critical
change
of that.
behaviors,
Yeah.
etc. But in this case, it worked. But there, and that's the crying eye, if you will, to stay by my weird saying,
Yeah.
is that most likely the chemical industry that clearly made a business with those chemicals that caused the depletion of the ozone layer
Yeah.
had already done innovation to replace that chemical with others
Yeah.
that were viable and probably also as cost efficient.
Yeah.
So it wasn't an economical issue to replace those chemicals. So I'm gonna leave it there. Back to your hope.
I do have hope. I have hope in climate action. So on the planetary boundary of climate change, I have hope in climate action, however big or small it can be. I think the COPs are climate action. So I have hope that with thousands and thousands of people at that conference every year, there is something that's happening.
COP being the Conference of Parties.
The Conference of Parties.
There
is something that's happening that people talk about, and all the different COPs. There's one on biodiversity, there's one on migratory birds that you talked about the other time. There's one on wetlands, which is about fresh water in wetlands. There's a lot of these COPs that happen, and I have hope on the fact that there is some action that's being done other than shutting down the whole idea that there is something going on and that we need to do something. So I have hope in that. That's my first hope. My second hope is, I will say it again, this podcast, having to talk about difficult things and share it with others. I think it's hope that whoever it reaches, they get a bit of the information of what's needed. It might tug, a bit of okay, let me do something about this. But that's my second hope. I don't remember my third hope.
But we have 3 among the 2 of us.
Yeah.
That's more than 1 each.
Yeah. So see, we have a lot of hope, and that is the reason why we come here smiling every recording, because there is some hope. Yeah. Thank you so much for explaining. You explained all the things for me today. I'm gonna have to go sit down and read about it.
We're gonna post some information as we usually do.
Links to the planetary boundaries, links to tipping points, links to the AMOC.
Exactly.
To the AMOC. We're definitely going to have to post so many links under this episode because it was heavy.
Yeah.
It was deep.
We don't expect everyone to read all of it.
Yeah. But if you just want to check it out.
Yeah. Send us comments. and we'll address them next episode.
Like and subscribe. We hope to connect with you every time when we do this charts. So see you next time.
See you next time.
All right.
Thanks for tuning in.
Bye.
Bye.